All right, 4.3, we have 3 new rules of inference here, so we'll add some extra complexity to doing the proofs here. First, you have to understand the rules so you can go forward, same as in the other case. So let's take a look at what we have here. We got hypothetical syllogism, abbreviated HS. We have if P then Q, if Q then R, and from that we can conclude if P then R. Definitely thinking about what these symbols mean and talking it out as I just did is helpful. Remember, the order of the premises does not matter, so the same rule would be, well, let me write it in a different way. Let's say if I have if P then Q, and if S then P, I could conclude that if S then Q. Same inference, the order, so to speak, of the premises are flipped. Sometimes you want to read them in the opposite way to understand what's going on. Some other instances of hypothetical syllogism would be, let's try a negation and an and. So let's say I have not X implies A and not B. And then I have A and not B. That's got to be retained as a unit, implies C. Think about what would follow from that. Hopefully you come up with if not X, then C. Again, regardless of the order, it's easier to see intuitively, I think, as is written here. Another way to picture the rule, so you have circle implies box, box implies triangle. Make a big triangle there. All right. That would tell us that the first thing, calling it circle, implies the big triangle, which I'm calling there. And we can fit whatever we want in this circle and in this box. So, you know, I could make this a negation. Let's make them all negations because I don't have that much room. Let's make this, then I have to repeat the form in this case, not Y. And then let's go ahead and make this Z if and only if K. Just enough room there. I'd want the parentheses to group that as a whole, so indeed it can aptly be put in the big triangle here. What do we get from this? We have if X and not Y. If not Y, then Z if and only if not K. That tells us if not X, then Z if and only if K. Okay, we can take away those boxes and so on and so forth. All right, disjunctive syllogism is a bit simpler here. We have an or claim. If we have P or Q, we don't have P, well, then we have to have Q. That would be for, of course, any P or Q. So let's say I have if and only if and an or. Say I have A if and only if B, or C or not D, like that. It's an or claim. This is the main operator, the operator we do last, pictured right here. And so we fit the form for the first claim. Now to have disjunctive syllogism, the one and only one way we could do it would have negation of that first claim, and negate the whole claim, like that. The parentheses wouldn't actually matter in this case, but in many cases they do, and you can't just jump back and forth unless we have a rule. We're going to get rules for that. What follows? Think about what follows from the first and the second premise here, and hopefully you come up with C or not D. All right, let's move on to our most complicated rule. Let's talk about it intuitively first. We have P or Q. And then we have an and statement, which says if P then R, and if Q then S. So we got either P or Q. P implies R, and Q implies S. Think about what happens when you put that together, and you're going to either have R or S. Okay, we do mean inclusive or in both cases. If we have at least at least one of P or Q, we're going to have at least one of R or S. As long as we're consistent with the or, rule's definitely good here. Okay, so already complicated, but let's do one of some extra complexity here. Let's go with the not A or B if and only if not C. For our or claim, again, the or claim could appear second, but once we have this as our or claim, we want to construct a dilemma. We're going to have if not A, then I'm just going to say we can put whatever we want in there. I'm going to wait on that for right now. And we need it to be an and, otherwise we're not going to have a valid inference here. This time I'm going to need brackets. The Q, so to speak, is B if and only if not C. I'm going to have that implies some other thing. So let's just go with not B and C here. Perfectly general rule, so repetition is not a problem. Following the patterns are quite complicated. Stop, pause, see if you can think about what follows here. And what follows is the consequent of the first if-then, which is not B, or the consequent of the second if-then right here, C. And that's how we would do that rule.